Okay, so when we're working with angles in 3D, it's actually not any different than Anna, Edwin. It's not really any different than in 2D. You just have that third component. So if I, for example, want to find the angle between vector v and u, no matter if they are in a two-dimensional plane or a three-dimensional plane, it's actually still a two-dimensional situation, right? So if you're finding the angle between two vectors, no matter how they're oriented, it's still a two-dimensional thing. So you use the same formula, you just have an extra component when you're doing the formula if you're working in 3D, but it's still just this cosine of theta is equal to u dot v divided by the magnitude of u, magnitude of v. Okay, we are still using this exact same thing in 2D or 3D. Okay, and we're going to use that to find the direction angles, which I think was what people were confused about. Okay, so the direction angles, we have 3 of them. Okay, so if we have a vector v, that vector v in 3D has 3 direction angles. So let's do, yeah. Okay, so if I have some vector in 3 dimensions, it has 3 direction vectors. It has alpha, which is the angle formed by the vector and the positive x-axis. Beta is the same thing, but the positive y-axis. And gamma, same thing, but we're finding the angle between that and the positive z-axis. So if we are looking for the easiest, so we just need to figure any vector along the positive x-axis. What do you think is the easiest one to use? I think somebody said it. Okay, so the unit vector along the x-axis is I, right? So in 3D, that's 1, 0, 0. In the y-axis, we are going to use j, which is 0, 1, 0. And in the z-axis, we're going to use k, which is 0, 0, 1. Okay, so all we are actually doing is using this formula that we just talked about up here. And our v is that v, and then u is whatever unit vector we're using to find that angle. So if I want to figure out alpha, I'm going to show more work than necessary for alpha, and then you'll see the pattern, and it's actually really easy. But if I want to figure out alpha, that's cosine inverse of u dot v, so that's 1, 0, 0 dot 2, negative 4, 3, divided by the magnitude of u, which is 1, times the magnitude of this, 4 plus 16, 20, 29. Okay, so what's the dot product of those two things? It's just 2. Okay, so we have cosine inverse of 2 over the square root of 29. And you type that in your calculator. Okay. I'm running out of room, sorry. For beta, guess what? It's cosine inverse of the y component of my vector divided by the square root of 29. Do you understand why? Because the other two parts of the dot product are going to be 0. Okay. And then gamma, what's gamma going to be? Which of these angles is going to be obtuse? Beta. Good. Okay, you would type those in your calculator. Sorry, I have one more thing. The last thing from this unit was just this. There's a proof of it in the textbook if you're interested. But if you do this cosine squared alpha plus cosine squared beta plus cosine squared gamma, that's not a gamma, it's equal to 1. There's a proof of it because it ends up being a unit vector. So you can look at the proof of it in the textbook.